So as steps then for factorising polynomials, we can use trial and error to find some integer 0, alpha, by solving p of alpha equal to 0. Now, I don't mean an integer, the integer 0. What I mean is a 0 of the polynomial, and it needs to be some sort of constant, so a number. So we want to just try some things. So find p of 1, is that 0? No. Find p of negative 1, is that 0? No. Perhaps try p of 2. Try a bunch of things until you find one. Then, once you've got one of the factors, you can use long division to find the quotient that goes with that. And then you can even divide that again using trial and error and long division. You could use that process over and over and over. Or sometimes if you've got something like a quadratic left over, you can actually factorise that using your normal factorising skills. Now, if it's not a show that question asking you about a particular factor or remainder, then my hot tip is use your calculator for the trial and error part, because otherwise this would be really slow. Now, you want to input your function, whatever it is, so your polynomial, using your red A anywhere that there is an x. So we're going to do this one step at a time. Grab your calculator now so that you can do this at the same time as I am. So we're going to put in x cubed here, but not x cubed, a cubed. Now a is the little red letter there that you can see on the minus sign. And to access it, because it's red, you need to hit alpha. So press alpha and then get your a up on the screen. And now hit the cubed button. So you've got it cubed. Plus 4, now we want a, so put your a back in again and hit the squared button. So now you should have a cubed plus 4a squared. Now we need plus a minus 6. So I've got my whole formula there for this one here into my calculator with a's where the x's would be. So that's first step. All right, press equals. All right, now we want to set the value of a, and we can make it be anything that we want to by putting some number in and then pressing shift store a. So let's try 1 first. So press 1 in your calculator, and now it's put in a 1. Now go shift store. Now shift is the yellow function, store is in yellow, and it's on that RCL button. And now hit the a, because we're telling it make 1 a, and it'll say it up there. 1 is now a, 0. Great, that's what I want. Now press your up button to reveal your formula. So your calculator will remember the last function that you put in. So if we hit the up button on our big cursor, it shows us that again, what we want to do with our a. Now we can hit equals, and it will make it recalculate that formula again using the most recent version of a. And sure enough, it's come up with a 0. What does that tell me? It tells me that the p of 1 was equal to 0. And that means that x minus 1 is a factor of this. So I just found a factor straight away. It was the first one that I checked. Let's check another one now. Let's let a equal 2. So with that, all of that right there, you don't need to press anything. Let's hit 2 and say shift store a. Now it's telling us that a is 2. Great. Now the up button and equals, and now it's calculating that with a being 2, and the answer is 20. So you could be showing your results quite easily here by just listing them. What about p of negative 1? Let's try that. Don't touch anything, there's no need to clear it, you can just put in negative 1. That will appear on your screen. Shift store a. Now now a is minus 1. Hit the up button, which is a nice way of just checking that it's using the correct formula, and then press equals, and now it will do it with our new a, and we get negative 4. So neither of these are factors, and you could actually, rather than using long division, if you were keen, you could use trial and error to find more of the factors. One limitation though is that you might end up with a factor that can't be fully factorised, so it might not be a neat, tidy one. So using long division is a good way to get around that. One last little thing, what if the 0 is not an integer? For example, find the remainder when this polynomial is divided by 2x plus 1. Now, we're used to dividing something that looks like this and saying, therefore, the remainder will be P of alpha. Now this one, harder to pick, but what's going on when we divide by this? When we find P of alpha, why is it alpha? Because it's the number that we could put in there to make this whole thing equal 0, right? So what number could we put in here to make this whole thing equal 0? Well, it's something plus 1, so this whole part needs to be -1. So this needs to be -1/2, doesn't it? -1/2 times 2 is -1, plus 1 is 0. So what we'd need to do then is find P of -1/2. So again, we could do this by hand and work out -1/2 cubed plus 2 times -1/2 squared, etc., etc. Or if we've got a bunch of these to do, all using this formula, it might make sense to put it in as an A and then let A be -1/2.